The grains show irregular outlines and have neither a banded appearance nor largely sub-rounded or subangular shapes, and the rock is probably an igneous rock. Most of the grains are between 0.25 and 2 mm in size, but some are up to 4 mm in size. Under plain polarized light, most of the grains are colourless or cloudy and have low relief, which means that most of them don't stand out from the section any more than the other grains. There are 3 minerals that can be recognised in plain polarized light because they form larger crystals. These large crystals are called phenocrysts. One of these minerals forms phenocrysts that are rounded subhedral crystals that are embayed. In plain polarized light, this mineral is clear and not pleochroic, that is, it does not change colour when the stage is rotated. It has low relief and shows no cleavage. This mineral is quartz. Subhedral is a term used to describe crystals that show some crystal faces. Embayed crystals are crystals that show irregular cavities penetrating some of the crystal faces. The embayed quartz crystals indicate that the quartz was not in equilibrium with the host magma and so was partially resorbed. This may be either because the magma was being superheated by mixing with hotter basaltic magma. Magma mixing is a common process in nature, or because of pressure release as the magma moved upwards. This pressure release would cause the quartz to become unstable. Minerals that form phenocrysts that have a slightly cloudy or turbid appearance in plain polarized light are feldspars. Feldspars are often turbid like this because of alteration. These feldspar phenocrysts are subhedral but are not embayed. They are not embayed because they were in equilibrium with the host magma. Some of these feldspars have a slightly higher relief than the quartz crystals, so they stand out more than the quartz. Looking at differences in relief to distinguish between these 2 minerals in plain polarized light is difficult, but the differences between the 2 minerals are clearer under crossed polars. Under crossed polars, the quartz shows first-order grey interference colours. These crystals show straight extinction when the stage is rotated. Although feldspars are a cloudy brownish colour in plain polarized light, under cross polars it is easier to see the outlines of individual crystals. These feldspar crystals show first-order grey interference colours. It's also possible to distinguish between types of feldspar by looking at the type of twinning shown under cross polars. The alkali feldspar here shows simple twinning, which is cross-hatch twinning. The plagioclase feldspar here shows multiple or lamellar twinning. Rotation of the stage in one direction results in the sets of lamellae going dark and reaching extinction. Rotation in the other direction results in alternate lamellae reaching their extinction position. Note that the mineral has an inclined extinction. This means that the mineral goes extinct when the elongate direction of the mineral is neither east-west nor north-south. Small amounts of another mineral also occur. In plain polarized light, this mineral has moderate relief and shows cleavage. The mineral is pleochroic and its colour changes. This is because the transmitted light is absorbed to differing degrees depending on the refractive index, which varies with the crystal orientation. Notice that as the stage is rotated through 90 degrees, the colour changes from yellow-brown to darker green-brown colour. This darker green-brown colour appears when the cleavage is aligned east-west. This is the mineral biotite mica. Under cross polars, this mineral shows up to second-order interference colours. It shows parallel extinction when the stage is rotated. This means that the mineral is extinct when the cleavage lines and the elongate direction of the minerals are east-west or north-south. The phenocrysts of quartz and altered feldspar are set in a groundmass composed of micrographic intergrowths of quartz and alkali feldspar or K-feldspar. This texture is characteristic of granophyre, sometimes called micrographic granite. This texture is visible in plain polarized light because of difference in birefringence of the two minerals, but these micrographic intergrowths are best seen under cross polars. Under cross polars, many of the quartz and K-feldspar crystals in the groundmass have a radiating arrangement. Under higher magnification, it is possible to see the details of these micrographic intergrowths. Note the white blobs of quartz when it's not in extinction and the darker patches of alkali feldspar in extinction. In summary, this rock is made of a mass of interlocking crystals less than 2 mm in size, but contains some larger subhedral crystals up to 4 mm in size. It is a medium-grained crystalline igneous rock which contains larger crystals called phenocrysts, so it has a porphyritic texture. The main minerals making up the rock are plagioclase feldspar, K-feldspar or orthoclase, and quartz. Small amounts of biotite mica also occur. The larger crystals or phenocrysts are made of quartz and altered feldspar. The quartz phenocrysts are embayed. Phenocrysts are set in a groundmass composed of micrographic intergrowths of quartz and alkali feldspar or K-feldspar. This texture is characteristic of a rock called granophyre, sometimes called micrographic granite. This rock is a porphyritic granophyre. It is an igneous rock that crystallized from a siliceous magma and placed in a subvolcanic minor intrusion.